So here is a random one-dimensional kinematic equation that I just found from some Regents exam. A race car starting from rest accelerates uniformly at 4.9 meters per second squared. What is the car's speed after it has traveled 200 meters? This should be our process for solving any type of question that we don't know. First step is to write down our givens. Excuse the terrible handwriting. All right, handwriting should be better. Let's write down everything that we know. Well, I know our acceleration. We're accelerating uniformly at 4.9 meters per second squared. Acceleration is equal to 4.9 meters per second squared. I know something else. I say it has traveled 200 meters. So I know my displacement is 200 meters. I know that we are starting from rest. So if we're starting from rest, I know that's our velocity. Initially, it's going to be rest, which is 0 meters per second. And I'm looking for the car's speed at the very end. That is our final velocity. But a big old question mark, I don't know what that is. Now, the next step is to find on the reference table which kinematic equation has acceleration, displacement, initial velocity, and final velocity. We want final velocity to be the only thing in the equation that we don't know. So we can go to our reference table. And this is our reference table. I know that I am working with a kinematic equation. And given that I have practiced using the reference table, I know that it's on the very last page under mechanics. So I'm looking for an equation here. Let me actually just take a screenshot of this so I can move it over. These are my kinematic equations. If I go back to my whiteboard and I paste it, that is not what I intended. This is what I intended. Come on, this way. If I go here, let's put it up there. Let's do it there. So, are there any equations here that have acceleration, displacement, initial velocity, and final velocity? Well, we're not working with that first equation. The second equation, acceleration, velocity, but we don't know time, so here we have final velocity, initial velocity, acceleration, but time we don't care about. Here we have displacement, initial velocity, time once again. We're not going to use that. Our last kinematic equation, we have final velocity, initial velocity, we have acceleration, and displacement. Excellent. So that means we can use this equation. Final velocity squared is equal to initial velocity squared plus 2AD. I need to isolate my final velocity. That means take the square root of both sides. Initial velocity squared plus 2AD. Now we can go ahead, since final velocity is isolated, and just plug in everything that we know. Final velocity is equal to the square root of initial velocity squared. Since we know initial velocity is 0, this entire thing goes to 0. I can just omit it, pretend like it doesn't exist. Now I'm left with 2 times acceleration, 4.9 meters per second squared, times displacement, which is 200 meters. Take the square root of all that. Boom. And let's actually see if I have my graphing calculator. No, it's not Weebly. Let's called wabbits. There you go. Oh no. Do I have it? Here it is. Spectacular. I have my graphing calculator. So I can go ahead and plug this in. I can do the square root of 2 times 4.9 times 200. Once I find that, I have my final velocity is equal to 44.3. What's our unit for velocity? Meters per second. 44.3 meters per second. Look at that. Let me just box my final answer. Good practice. Look at that. Number 3. So the idea is that no matter the problem that you encounter, you can follow these steps of writing down everything you know, looking at your reference table to find the one equation where there is a single unknown, then isolating the variable, and finally using our calculators to get to the final answer. I hope this helped. Good luck.